Good afternoon. We'll continue our discussion on the jacket platforms. Today we will see the construction and installation of these jacket platforms. The jacket platforms are fabricated in a yard. So what we see to our left is basically a yard wherein we have the legs, or what you call as the columns of the jacket platform. Actually, the jacket platforms, once completely fabricated, is transported using a barge, which we had seen in our previous presentation. So before we actually make this column, we need to keep some attachments which will facilitate the movement outside once we complete the full fabrication. So we have this timber runners. To support the timber runners, we have the slippers and the prefabricated skid beams. Okay, and these columns, as you see, it is not like a single long cylinder. It's actually a number of tubulars that are welded together to form one single large column. And we need to actually provide some stiffness inside these columns along its length so that it will have enough strength. It's like a strengthening mechanism that is done for these columns. Okay, and what we see to our right are the bracings, which is of X type. We had seen different types of bracings in our previous presentation. So this is the X type of bracings. Okay, so having fabricated the columns and the bracings separately, we bring it to an assembly point wherein these bracings are actually welded onto the columns at marked locations. There will be some marked locations wherein it is force fit and then it's welded. And these points, they act as points of very high stress concentration and have to be designed and welded very carefully. And also you can see there are a number of temporary, these are leg pods which actually assist the placement of the columns and bracings according to the geometry. And once we keep this vertical bracings, we can box this section. You can also see a number of pile guides are also being placed. Similarly, the remaining columns and bracings are also integrated at a separate location and is brought to the final assembly, and they're also assisted by these are the leg pods that we had seen previously. So they're all boxed up together to form a one single platform. Before we load out the jacket platform onto a barge, a mud mat is provided beneath the jacket platform. This mud mat acts as a temporary support and provides stability to the platform when it's placed on the seabed. Because when we just place the platform on the seabed, there is no piles to support the platform from the environmental loads. So these mud mats will be providing the temporary support from any sliding moment or any overturning moment that will be acted upon by the wave as well as the current loads. At this instant, we do not have much effect of the wind because we are not actually keeping the superstructure on the top of the platform. It is just the jacket alone. Also, buoyancy tanks have to be placed. Now, the jacket by itself would definitely have some amount of buoyancy, but would it be enough for the installation requirements? So, depending upon the designer, he would be suggesting that an additional buoyancy tank has to be placed so that we get the required buoyancy, in the sense that the whole jacket has to remain floating for the final installation procedure of upending. So an additional buoyancy tank might have to be provided. Also, before we actually load out, grout lines needs to be installed. You can see these grout lines here towards the skirt legs, and also a number of caissons needs to be also placed. And finally, in a small region towards the top, there's a position for keeping the slings for the upending procedure, which we would be seeing in the subsequent slides. The fabrication of the jacket is completed in the yard. We'll look at the sequence of installation of the jacket. The first process that's carried out is the loadout. Loadout refers to the transfer of the jacket from the yard to the floating barge. So this can be done using any suitable mechanism. So once on the floating barge, the jacket is taken to the region of interest using tugboats. So once we reach the marked location or the region of interest where we are supposed to install the jacket is launched from the barge to the seawater. In this process, the jacket is actually horizontal. Now, this horizontal jacket is turned to an upright position, that is the final service condition of the jacket, using a crane. This is followed by the pile installation. This is what we were discussing, the time between the upending and the pile installation, for which the mud mats would be supporting the jacket from overturning and sliding, and finally the superstructure installation. This is a floating barge. It's a flat bottom barge. These are the type of barges that is specially being used for this jacket installation process or the loadout process. There are these rails on which the jacket needs to be brought in. There are several mechanisms by which we can actually do this, that is through a pivot pulley arrangement or using trailers also. This can be achieved. These are generally lubricated so as to reduce the friction. Only the substructure, this jacket, is only brought into location by barge. The superstructure is generally brought by crane, because you don't want the superstructure to be launched in water, because they're very critical equipments and they are directly brought using a crane. There are several other types of superstructure installation. We'll be seeing it later. And one more crucial point, that is, this is a pivot element. It can be rotated. So this would be actually facilitating the launch of the jacket onto the seawater. Also, it may be noted that at the interface between the barge and the yard, there is something called as a fender, because this fender actually prevents the crashing of the barge to the yard. This is the pivot and pulley arrangement that I was talking about. So there is a stroke motion in this direction which would actually facilitate the movement of the jacket platform towards the barge. So once the jacket is placed on the barge. There are a number of support structures along the rails which are welded and attached so that the jacket does not slip off during the transport process, and also several tugboats are also attached to be ready for the transportation. These are images of jacket platform being transported to the region of interest. This, towards the right is the Bullwinkle platform that we had seen previously. We can see that there are a number of tugboats all around the central barge. A number of tugboats are kept all across because any uneven motion, like any sway motion or any roll motion, can be avoided. That's why, to balance, to give an overall balance effect, the tugboats are kept. These images show the launch process of the jacket onto the seawater. So once the barge is brought near to the region of interest, a certain portion of the barge is ballasted with water so that we can obtain a small inclination. It is generally 3 degrees depending upon the coefficient of friction. The jacket may slide onto the seawater, or in some cases winches or even hydraulic jacks are used to assist this process. The barges that are used for this launch purpose are actually divided into a number of compartments. Now these compartments can be flooded with water so that we obtain a angular arrangement so that the launch can be carried out. So the jacket begins to slide, and then through the pivot point it actually falls into the seawater. Now here comes the crucial effect of the pivot point. The pivot point that we'd seen previously acts like a dive board so that the jacket just slides off through the pivot point such that the bottom portion of the jacket does not crash onto the jacket structure, causing a damage. So the previously placed buoyancy tanks as well as the inherent buoyancy of the jacket would enable it to remain in a horizontal position. This is the rocker arm here that we were discussing, which would facilitate the movement of the jacket onto the seawater. Now this is the barge here, and the compartments towards the side of the rocker arm needs to be ballasted with water so that we get a 3-degree inclination and the jacket smoothly slides onto the seawater. The railings were also previously lubricated so as to reduce the coefficient of friction, but in some cases even winches or some hydraulic jacks may be used to assist this process. It should be taken care that the barge is not ballasted to a great degree of angle. Because of this very huge mass being at one corner, there is a chance that the barge might get toppled and there could be an accident. One more interesting thing to note is that once the jacket is being launched to water, it should be taken care by the designers that the jacket does not crash onto the sea floor. So we attach these buoyancy tanks so that there is sufficient buoyancy and the jacket can come up. Approximately 5 meters to 10 meters is actually given as a tolerance with that of the seabed, so that any crash can be avoided in shallow waters. These pivot points, structures like this can also be seen in the swimming pools. It is done in such a way that this rocker arm would orient itself to the motion of the jacket platform, and the bottom portion does not crash onto the barge. Now once the jacket is released into the seawater, it remains in horizontal orientation with the help of the buoyancy tanks. This is because the slings that are kept for the next process, that is the upending process, is in this location, and in order to have an access to that, we need the platform to be in a horizontal position. Now this is the upending process, wherein the horizontal jacket that was in the seawater previously is brought to a vertical position using a crane. Now you can imagine that what should be the lifting capability of the crane, because this jacket is a very heavy structure. It's almost as big as a very tall building, and it has a very high weight in terms of tons. The advantages of the cranes that are used for offshore installations is that it does not require counterweight in terms of mass like what is seen in land-based cranes. Instead, like what we had seen for the barge being ballasted, a similar counterweight is obtained by ballasting the chambers in the crane, which would act as a counterweight. Ballasting is the process of filling water into the chambers. And subsequently, what is done is that from the barge, using the flooding lines, whatever the ballast chamber that we had added in the sides for getting the additional buoyancy, those ballast chambers are filled in with water. During this process, what happens is there is the change in the center of gravity and the center of buoyancy of this jacket, and this manipulation that is done is termed as the upending process. Now it is interesting to note that the valves of the buoyancy chambers need to be timed in a very good manner, because if not timed properly, there is a chance that the jacket may overturn. So as we go on lifting the jacket, the ballast chambers need to be filled in with water so that finally we get an upright position, and then make the movement slowly downwards. The image to the left shows the jacket being appended using a crane, and these are the slings that are attached to the jacket. As we slowly move the jacket to a vertical position, the buoyancy chambers are slowly flooded in with water, and there's a remotely operated vehicle that actually times the valves of the buoyancy chambers and is brought to a vertical position. And further filling of the buoyancy chambers would result in the complete movement of the platform towards the seabed. And the target location is achieved by the use of GPS as well as gyros.